This is for the project for determining the rotation of the Earth using the Foucault Pendulum, and it's the Wikipedia page, obviously. And its only claim to fame in a trigonometry class is actually this one right here, that the rotation period of the Foucault Pendulum in a given location needs to be multiplied with the sine of the angle. That is, I'm sorry, the sine of the latitude. And that then gets us the rotational period of the Earth, which is not 24 hours, it's 23 hours, 56 minutes. But again, that's actually what you have to figure out in this particular exercise. The Foucault pendulum itself is a simple pendulum with a very heavy mass on a very long string or wire. As you can see, this goes all the way up here, and then is able to rotate in this plane here because the Earth actually rotates underneath it. So it's also a proof for that the Earth is rotating. Now, these are the hallmarks of a Foucault pendulum. Other than that, the design can be any which way. So the way I have it here at the Anchorage UAA Consortium Library, if there's still a video accompanying this one here, then you can see someone filmed that particular one, and you see there is this octagon shape. Actually, it's a dodecagon. I looked it up. And then the railing is relatively close to it. And then you have these names here with these degrees. And again, someone else actually took that accompanying video while I'm doing this one here. These are my measurements. The last one, by the way, disregard that. That's just here to show you that I put my name on there too. Long time ago, more than 10 years ago, I believe. But these others here are measurements that I took on these days here, so the 10th, the 11th, the 12th of 2019, January 2019, in the morning, evening, in the evening, and then again in the morning. And the reason why I have two sets here is because as the pendulum is swinging left to right, well, I took a measurement on the left, I took a measurement on the right. And basically, everything is actually here. So here are the times, and here are the degrees. And I labeled them such as you can see Linda here, and then 344, and here's Joyce, and there's 160. Or here, let's see, 49th, that's apparently 249 degrees. So you take these here, and you plug in these degrees. You can see it says Joyce here and Linda and 49th. So here's Joyce, 160, and here's Linda, 344, and here's 49th, 249. Apparently I didn't put them in the correct order here as far as the table is concerned, so that's a little bit, but you can see I labeled them here. So Stan here comes out to 71 degrees, Helena comes out to 305 degrees, and, well, might as well put the last one in, 124 degrees. Okay, now comes my example calculation. Here's what you do. You have the times listed in the front here, January 10th through the 11th, 7:55 to 5 p.m. That's just short of 21 hours. In fact, if you plug it into the calculator, it's 20.9 hours. So the entire pendulum plane rotated in 20.9 hours from an angle of 160 degrees going through 360 and then arriving at 71 degrees. So 160 to 360 is 200 plus the 71 is 271 degrees. So that's how the pendulum rotated horizontally. And I think I'm also going to post a video showing you a time lapse of that as well. And now here, you use this formula here. So the period is 360 degrees times the 20.9 hours divided by the angle that it rotated through, 271. When you plug that in, you come up with 27.8 hours. That's how long the Foucault pendulum in Anchorage would take in order to rotate once around its plane. That does not match the rotation of the Earth of 23.9 hours because this is an anchorage. So you would have to multiply by the sine of the latitude. You'll do that later. Once you have these results here in the back, you will get 4 results. Now, of course, you have to fill in these here too. And I just did this for you here, so just have to copy them or from the photos. And you have to compute these here, and you will get 4 results. And then you take an average of these 4 results. And then after that, you divide by the sine of the latitude. And you should come out with something really close to 23.9 hours. Okay, last thing I want to show here is if you happen to be in Anchorage, you're free to, or anywhere where there's a Foucault pendulum in the lower 48 or anywhere on Earth, you can visit there and follow the instructions here and take your own measurements. But the likelihood of that, well, it's there if you're in Anchorage. But other than that, I already have everything posted here, and technically everything is actually on this adapted lab for my astronomy class.